For this question, we want to solve the exponential equation 5 to the x squared plus x equals 25. Looking at the bases in this example, I've got a base of 5 on the left and a base of 25 on the right. Because 25 is the same thing as 5 squared, that means I'm going to be able to write both sides of this equation with the same base. So I'll solve this equation using the relating the bases method. I'll be able to write 25 as 5 squared. And with the relating the bases method, or sometimes called the one-to-one property, you get this situation. Base to the u equals base to the v, so we have the same base on both sides of the equation. And this one-to-one property, or the relating the bases property, says anytime you have that situation, the exponent on the left has to equal the exponent on the right. So for our example, because we have the bases being the same on both sides, we're going to be able to say that the exponent on the left, x squared plus x, has to equal the exponent on the right of 2. This gives me a quadratic equation. I'll move all the terms to the same side, and I'll try to solve this by factoring. Of x and x, factors of 2 are 2 and 1. I'm going to put a plus on the 2 and a minus on the 1. And I can set each one of these factors equal to 0 to get x equals negative 2 and x equals positive 1. These are the solutions to that exponential equation. 5 to the x squared plus 1 equals 25. For this example, we want to solve the exponential equation. 4 to the x over 5 equals 11. Looking at the bases, I have a base of 4. 4 can be written as 2 squared. And a base of 11. 11 is prime. There's no factorization that will allow me to rewrite that base of 11. So because I can't match these two bases, I can't use the relating the bases method to solve this equation. I need to use one of the other methods. And one of the other methods is to take the log of both sides. I can take the log on the left, and I can take the log on the right. Introducing the log is allowed because of the one-to-one property of logarithms. And the other really good thing that it does is it allows you to use your log properties, especially the power rule here. And the power rule allows you to take that variable out of the exponent. It becomes x over 5 natural log of 4 equals natural log of 11. And I'm going to get rid of this fraction by multiplying by 5 on both sides. That's going to cancel out the 5 on the left, giving me x natural log of 4 equals 5 natural log of 11. I got an extra line right there. And now I can get x by itself by dividing both sides by natural log of 4. So my solution is x equals 5 natural log of 11 over natural log of 4. We have another technique for solving this equation, this exponential equation, and that is to convert it to a logarithm. So the same equation, 4 to the x over 5 equals 11. What we can do is rewrite this exponential equation as a logarithmic equation. We would write the word log and we're going to use the base of our exponent. That's base 4. The log always equals the exponent. We have an exponent of x over 5, and then the 11 is what goes inside the log. Now we want to get x by itself, so I would multiply by 5 on both sides, and I have x equals 5 log base 4 of 11. And this gives me my solution. Now, even though this solution and this solution look different from each other, if we were to type those in our calculator, we'd get the exact same answer. They are just different forms using logarithmic properties. Thank you for checking out my videos. Have a great day.